All right, so if you're good with all of that, then one thing we can also talk about is what's called ionic radii. So as we know already, some of these guys are going to be able to gain and lose electrons. So let's say sodium. Sodium has 1, 2, 3 energy levels. 1, 2, 3 energy levels. We know it only has one valence electron right there. We know that it has 11 protons in the center. 11 protons in the center. We know that between the second and the third energy level, these guys are going to have a grand total of 10 shielding core electrons pushing away that one. We know that this guy has a Zeph of only a 1, which means it's going to have low ionization energy. I hope you're catching all that. I hope it's all kind of blending together now. So now, since it has a low ionization energy, what we can say is that sodium will have a propensity, a likelihood of forming a sodium +1 charge. It'll form a cation, an ion. So question is, when it goes from being sodium to sodium +1, does it get bigger in size or smaller in size? Hopefully you can think about it for 1 second. It's easy, it gets smaller. Why does it get smaller? Because if it lost that electron, that whole shell goes away. If that whole shell goes away, 2 shells, of course, are smaller than 3. Okay, now the other one that's not as obvious is, let's say, fluorine. Fluorine has 1, 2 energy levels. 1, 2, fluorine's right there. 2 energy levels, 2 electrons on the first. 1, 2, 3, 4, 5, 6, 7 on the second. Zeph of a 7, high electronegativity. What is electronegativity? The ability to pull in another electron right there. So it has the ability to pull another electron in right there. It has a strong ability to pull that electron in. It has 9 protons in the center. Just had to double check for some reason. 9 protons in the center, Zeph of a 7, pulling it in. Okay, now, fluorine will therefore go from fluorine to a fluorine with a -1 charge. It'll form an anion. Question is, does it get bigger? Does it get smaller? Does it stay the same size? What's going to happen? Not as easy to see. It's going to get bigger, slightly bigger. And the reason why is, same number of shells, second energy level, but now we're adding an extra negative bit in here. And so what do those negatives do? They cause a slight bit more repulsion. And so what's going to happen is these are all pushing away from each other, and when you add the extra guy in there, it pushes it out a little bit more, so it gets a little bit bigger. Well, now we can look at 3 guys together. Let's look at fluorine, neon, and sodium. But not just fluorine, but fluorine -1. Neon and sodium +1. Well, what do they all have in common? All 3 of them have 1, 2 shells. You go, sodium, 2 shells? Yes, it lost its 1 electron. So they both have, all 3 of these have 2 shells, and they're all 3 going to have 10 electrons. All right, 2 in the first, 8 in the second. All right, fluorine gained 1, neon is as is, sodium lost 1. What we say is these are iso, like an isosceles triangle, has the same sides, isoelectronic. This is an isoelectronic series, which means they all 3 have the same electron kind of configuration. Now, question is, which one's the smallest? Which one's the biggest? Well, makes sense. This guy right here has got 11 protons, 10 protons, 9 protons, and so 11 protons is going to pull it in the tightest. 10 protons will pull it in a little less tight. 9 protons will pull it a little less tight. And so as a result, This guy's gonna be the smallest of the three of these. Once again, Coulombic attractions, electrostatic attractions, opposite charges attract, and if we have greater positives in the center, it's gonna pull it in even tighter. All right, so that's what's it's just kind of one of those little we're just really kind of feeling our way through all this. All right, I think that's it.